Hi students, in this video we are going to discuss few problems related to applied math. So let's start. So as you can see that the question 1 is determine whether the ordered pair 1 comma minus 1 is a solution for the system of linear equations. As you know that what is the solution? The solution of a system of equation are the values that the variables that make all the equations true. Okay. So, and the solution of system of linear equation represented by an ordered pair. So, if this is a solution of this system of linear equation, then this must satisfy all the equation. Okay, so let us see. So what is the first equation? X minus y is equals to 0. Substitute the values here. So what is the value of x here? 1. So you can put 1 here. 1 minus of minus 1. So what is the value is coming? It is coming 2. And you know that 2 is not equal to 0. Similarly, again you can put here minus 2x plus 2y is equals to 2. On the place you can put the value minus 2, 1 plus 2 minus 1 is equals to 2, and you are getting here 4 minus 4 is not equal to 2. So you can see that this ordered pair is not satisfying any equation. So it means 1 comma minus 1 is not a solution. Okay. So in this way you can identify whether whether the ordered pair is a solution for the system of linear equations or not. If the ordered pair satisfies, then it is a solution, and if it not satisfy, then it is not a solution. Let us go to the question number 2. The question 2 says the arrow diagram given below defines a function. This picture is defining a function. So, as you know that in a function, all input values are known as domain and all output values are known as range. So you can see that if f is defines a function, these are your input and these are your output. So this is your domain and this is your range. So what is the domain of f? The domain will be a, comma b, comma c. And what will be the range? The range will be d, comma e. We will not take f because this output value is not taking any point in the domain. Okay, so this is your domain and this is your range. Let us go to the question number 3. The question 3 is the following arrow diagram represents function. Which type of function is it? Students, as you know that there are three type of function. One, one to one, on to, and both. Both one to one and on to. One to one and on to. Right? What is the condition for a one to one function? If for every element, if for every element in B, if for every element in B, there is maximum one element. There is maximum one element. For one to one, maximum one element. Maximum one. For onto, there is at least one element. At least one element. And here, exactly one. exactly 1. Okay, so look at here. For the point W, how many elements are there? There are two elements in A, 3 and 4, right? So it is for 1 to 1, for each element in range, there can be maximum one element in domain. But here, what is the problem? It is more than one. For x, there is only one element, 1. For z, there is only one element. So, this function does not satisfy the condition of 1 to 1 because the w is having how many element? More than one element. So, this is which type of function? This is on to function. Let us go to question number 4. Question 4 says that determine whether the given graph represent a function or not by a vertical line test. Student, there are two type of tests in a function. One is called vertical line test, another is called horizontal line test. Horizontal line test. Horizontal line test. Vertical line test is used to check whether the graph is a function or not, while horizontal line test is used to test whether the function is a one-to-one function or not. So you can look at the graph. So the what is the vertical line test? The vertical line test can be used to determine whether a graph represents a function or not. So how to perform the vertical line test? If we can draw any vertical line, if we draw any vertical line like this, if we draw any vertical line here like this, if we can draw any vertical line that intersect a graph more than once, more than once, you can see that whatever vertical line you are drawing, you cannot intersect this graph more than one. So it means by vertical line test, it is a function. It is a function. If this any line can intersect the graph more than once, then it will not a function. But since all lines maximum can intersect the graph only once, so it is a function. Let us go to the next problem. Find the domain of the function fx. Now, as you know that whenever there is a denominator, whenever there is a denominator in a function, we want to include only values of the input that do not force to denominator to be 0. So whenever in any function there is a denominator, in order to find domain, we just equate the denominator equals to 0. So 1 minus x square is equals to 0. So you have to find the value of x from here. So as you can know that this is a perfect square. Sorry, this is the difference between two squares. 1 square minus x square. You can write 1 minus x, 1 plus x equals to 0. And from here you can know that the value of x is equals to minus 1 comma 1. So the domain of this function will be the set of all the real numbers. So what will be the domain? Domain will be the set of all real numbers except minus 1 comma 1, right? So because this point minus 1 comma 1, if you put here this, it makes the denominator 0, and in that case it is not defined. Okay, so what will be the domain here? All the real number except minus 1 and 1. So for this video, that's all here. And students, we are advising you to solve the similar questions from your practice book for the more understanding. Thank you.